Okay, all right. Okay. So, real quick here, let's discuss kind of the idea, the question I want to talk about. The question that I want to discuss is something like this. Okay. All right. This is the type of problem I want to discuss. I want to discuss how to do it. I want to talk about how do you find a second derivative to something like this. I think there's one that you have to find a second derivative for a fraction.
Yep.
I want to discuss it. I kind of gave some hints to some people that tried it yesterday. I consider this one to be the more challenging question.
Put it to the top and it's the same thing.
What was that?
You just put it to the top and it's the same thing.
Yes. So that's what I would do. I would move the bottom up and make it a product rule, and then I would do the two derivatives over that. It will get messy. You're going to see it here in a minute. This is my only problem I want to do today. There was another problem that I know is long. It was the problem where it was like something with a 3 and something with a 2. Okay?
That one was way harder than that one.
Yeah.
I don't know if it was. Now, here's the reason why I would say that it's not that problem. That problem you had to find a second derivative on that thing. Here's why I would say it's different. You're just doing normal like product rule. Derivative of the front times the second plus the derivative of the second times the front. You simplify that mess, and yeah, it's long, but simplifying. Yeah, you'll have to FOIL stuff. That's not hard. And then once you get that, then you take the second derivative of it. I watched a couple people attempt it. They did a pretty good job. Now, I consider this one to be the more challenging one because it gets super ugly, and you can't simplify it. You can't, like on that one, you could cheat this problem. What I mean by cheat this problem, you could write 3 of those out, FOIL it, write 2 of these out, FOIL them all together to get one huge polynomial across your board, and then just do a derivative of it and do a derivative of it again. And you wouldn't have anything complicated to do. You could cheat it. That's a quick way to do it. Okay? Now,
I'll do it again.
so now some people didn't, and that's fine. If you didn't, you actually probably got to the answer a lot faster than somebody foiling that whole mess out. Okay, now.
I just really hope these are participation points.
Now.
I hope so.
Now.
Oh, okay.
Now.
Is this one?
This one is tough. This one, you cannot simplify it. You just have to go through the process of it. I want to show you how to attempt this correctly. Okay, now, I'm going to lose some people in the process of doing this. Good luck to you. Figure it out. Okay, so, all right.
I don't like this new word.
All right, well, you're going to have to deal with it. All right, so.
You seem to not care about me.
Okay, all right. Here we go. First derivative. Before I move to that first derivative, you need to change this problem like we were saying. Move this thing to the top and make it a negative power. Okay, so this in the parentheses is 3x squared plus 3x. And then we have the 5x, or 5 plus x, all to the negative 1. All right, now why I would change this problem before I start is because when I do the second derivatives of these, when I actually go through and do the derivatives, I would rather have it in a product rule than a quotient rule, because a quotient rule will be really nasty and things kind of everywhere and I have to FOIL and all that good stuff. Okay, now, I'm going to do it this way so I don't really have to do any simplifying. Now, it will require that you're really, really strong at knowing your product rule. So, derivative of the front times the second plus the derivative of the second times the front. And you really have to know that. So, okay, here's the first item, and here's the second item. So when I say I'm taking the derivative of the first, so you better know what I'm talking about. Derivative of the first times the second plus the derivative of the second times the first, right? You better know that this is the product rule that I'm using here in a second, okay? Because I just don't want to have to explain it 17 different ways. All right. Now, let's go through the process here. So, derivative of the first item, this ends up being a 6x to the first plus 3. That's the derivative of the first parenthesis, right? Drop the power up front, subtract 1 off, drop the power up front, subtract 1 off. Times the second. The second didn't change. Plus Now, we're in the plus now because it's the product rule. The derivative of the second item. The second item is a chain rule. Drop the power out front. Subtract 1 off the power. And then take it times the derivative of the inside. Well, the derivative of the inside is 1. But that's the derivative of the inside, right? It's chain rule. And then we have to take it times the first. 3x squared plus 3x. Now, what you're looking at here, that is the first derivative only. First derivative only. It's ugly, right? I know it is. How I would do this next? Question?
Can we do 2 separate product rules for that?
That's what I'm about to do. Yes.
Sure.
So, yes. So what I'm about to do now is go on to the second derivative. Before I do that, I'm just going to clean up something. What I'm going to clean up is this like craziness back here. Because you have like 1, 2, 3, 4 different things being multiplied together. I'm just going to multiply 2 of them or 3 of them together to make it so that I only have 2 items being multiplied together. So like a product rule, if you didn't hear Jared there. He said, can I just do a product rule? Yeah, you're gonna have to do it here, and then a product rule back there. Question?
I would do that last part, like from the plus to the right of orange.
The derivative of the second, it's chain rule. Drop the power up front, subtract 1 off the power.
Okay.
Drop the power up front, subtract 1 off the power, and take it times the derivative of the inside.
So you just
That's
put
the
one.
derivative of the second item.
Alright.
And then we have to take it times the front.
Okay.
That's the chain rule. Question? What was the question, Mom?
You just get rid of the one, so it's just multiplying.
Yeah, exactly. So I'm just gonna multiply. Even if that was like, I think on one of your problems it's like a 3 or something like that, or a 2. What you're gonna do, whatever these numbers are, this -1 and a 1 and this parenthesis, I'm actually gonna multiply these 3 things together. In fact, I'm gonna underline that. I'm multiplying this -1, this number, and this parenthesis together, like distributing it. The reason why I wouldn't do it to this parenthesis is that parenthesis has a weird power on it, and you can't distribute over a power like that. So I'm gonna ignore that. So all I'm doing right now is cleaning it up a little bit before I get started. So far I'm sitting at the first derivative still. The front really hasn't changed. What do we have? 5 plus x to the -1. And then back here, I'm going to clean up a little bit in the back. I'm just kind of fixing it so it looks a little bit easier, because right now that's a nightmare to look at. -1 times 1 is -1, and I'm going to distribute it over this mess. So -1 times everything there. So that's -3x squared and a -3. Is it an x? X. Thank you. Yep. Okay, so all I did, again, I took -1 times the 1 times the 3x squared plus 3x. The reason why I'm doing that is I want to get it cleaned up so that I just have 2 parentheses and not like 4 things being multiplied together. Okay, does that make sense what I just did? Like simplifying a little bit. Now I'm going to take the derivative again, right? The second derivative. And this is the part I think some people are getting like massively confused on, because I can't do anything to that. I could move this thing to the bottom and make fractions and kind of do ratios. I don't want to do that. I'm just going to take the derivative as it sits. Okay, so you could do that. You could move it down. Some people like that. If you're really good at quotient rule, you could do it. I would leave it here and just go further. Question?
So I left the -1 out front.
I think you could still get away. I think you'd still get
Okay.
away with it. Yeah, you could still get back to the 1 effect in that.
So then I had like +2 and the -3.
Yeah, yeah. I saw a hand over here. Somebody have a hand up? Okay. All right. Okay, so now what I'm going to do is I'm going to take the derivative. Now this is the part that you got to kind of follow along. To do the derivative of each item, right? Because these are being separated by a plus. The derivative is like taking the derivative of the front item here. This is a very long derivative, this thing. And then adding the derivative of this thing back here. So to do the derivatives of each of those parts, you have to do a product rule again. So I'm going to have a couple items here separated by a plus, a couple items back here separated by a plus, because this is a product rule again. that's how you do this. And this is the part that I know some people are going to get massively confused on. Okay, so the derivative of this item, so derivative of the first times the second plus the derivative of the second item times the first. Okay, so there you go. So that, what you're looking at here, that is that derivative. It's like, it's what we just did over here. It's a product rule. Derivative of the front times the second plus the derivative of the second times the front. And then I hit the plus sign. That's this thing right here. That's that plus sign. And now I'm doing the derivative of the back item. And that's also a product rule. So the derivative of that, this item back here. Derivative of the front. Derivative of the front. Times the inside. Right? Times the second. Right? Plus the derivative of the second times the first. This item's derivative is negative 6x minus 3, and that's the derivative of the second item times the front. Now, Morgan, you're probably wondering, like on yours, this isn't the specific problem, but on yours, you're like, mine look different, right? And like, if you're looking back at yours, you're like, well, mine was a positive 2 and I have negative,
Yeah,
right? Or
and then
something.
the other one
Yeah,
was-
exactly. Like these back here weren't negative, so like it still balanced out to be the same answer. It just looks different. So, all right.
Like on the test, if I didn't.
You'd be fine.
Okay.
Yeah, I kind of follow along to see where you put your negatives and whatnot. So, all right. Questions on how I did that? That was the answer, and I leave it there. That is really difficult. I consider this one to be the more challenging problem out of all 14 problems I gave you. Just because the second derivative is such kind of a mess. This unit in particular, it's not very long. I think there's only 4 sections or something. But as you're seeing here, this is the first section. They get messy because it's having you practice derivatives, but doing them like way different rules. Like putting products in product rule and putting quotients and changing them. Like it's teaching you all the weird shortcuts you should take. So that's my answer. All right, so is there any questions on that thing? Maybe I lost you somewhere and I can maybe try to salvage it.
You want to go to the second derivative again?
Okay, so this part right here, the derivative of just this thing is the part in green.
Yeah.
The derivative of this thing is the part in purple. So to do the derivative of this, you have to do a product rule again.
Yeah.
Derivative of the first times the second plus the derivative of the second times the first, right? That's a product rule. Derivative of the first times the second item,
All right.
right? Derivative plus the derivative of the second, which is this thing, times the first.
Oh.
Okay? And then back here, same thing. Derivative of the first, which is this mess, times the times the second, plus the derivative of the second item times the first.
And that's your answer?
That's my answer. It's a lot, I know.
See if I can get there.
Yeah. Now again, the one that had the crazy parentheses with 3s and 2s, a way to cheat that problem is to FOIL everything out before you start and then just take the derivative of that whole thing and then do a derivative again. That's a way to cheat that one big one with the parentheses like that. But these you can't. Like there's no way to cheat this problem. You just have to get through it. Again, there's different ways to do it. You could do it as a quotient rule. I just didn't want you to do that on any of these problems. I want you to change everything into product rule to get some practice with it. Eventually, we'll, like the next section, we talk about how to do a second derivative over quotient rule. That's what we do in the next section. So, I know. Sorry, it gets harder and harder as we go. Okay, homework. It's due tonight. Try your best, kind of work on it, submit it, do the best you can, try to type it in the best you can. I'm making the answer key as we sit, so if you want to see something, I can double check yours. I had some people double checking theirs earlier, but yeah, the rest of the time is yours. I just want to give you some time. I'm going to stop the camera here and give you some time where you just